Hi, my name is Elvin Kuci and I'm a student in computer science. What I've done in this project was to imagine how we will get the information and how we will process the data. That's mainly my job, like how we pass to the LiDAR information, to a PLY file, to finally have an object file. I also test how the image processing works, and I create different scripts to translate from raw data from the LiDAR to real data. What was hard for me was how the LiDAR sends the information. It's only distances, and it's pretty hard to process. We pass from just a distance to a 3D point in space, and after that we need to translate this to a mesh, an object in 3D. I also learned how to use Mushroom and the limitation of this software. It's a pretty hard software to use, and I'm pretty proud that it works. During this project I learned how to work with different people, not only computer scientists, but also electronicer, automatiker, polymechaniker. It was a really good experience, and generally I'm pretty bad when I work in groups, but here I had to work with people that are not only in group but also with a different job, and it was really interesting. I also learned how to really test my scripts. Create scripts to debug scripts to debug scripts. It was a hell. So just here we have a little program. It's named LPL to PLY. It's a script that processes the input. Here just a series of points at the same distance. To create a PLY file. A PLY file is like a cloud of points in a 3D space. If I run the program, we see it requests me what is the LPR file. The LPR is a LiDAR point record. It's how I named the file, the extension of the file. What is the number of points per rotation of the motor? Here, just for a value, we will say it's 500. So when the motor makes a full rotation, well, it takes 500 points. And so it generates out.ply file. And now, if I open it with a Blender, so if I open this file with Blender, just here, just import Stanford. We can see how the LiDAR take the data. Here is just with the default configuration, so we don't see as much as as we would. But here, each point is at the same distance of the center, which is this little thing just here. And yeah, that's all the data are represented. Here now we can imagine the ground just here, and maybe a rock here. It can show us this type of data. So yeah, that's just the script for the LiDAR. What I recommend is not programming when we are not totally sure about how we will get the data. I repeat myself with some code many times. It was exhausting. I think a good thing to do for the next time, if we do it again, is to have a better communication inside the group, and also for me propose my help to code the Arduino quicker. Generally what I think in this project was It was really good, it was really interesting. A good thing about it was for me programming and created the different scripts to process the data. I also like helping programming the Arduino. I really don't like the documentation. I think all my group didn't really like it. It was a lot of work for the good documentation. And also what I don't like, because I'm an informatiker, is my limitation in this project. I had not a lot of things to do, and I was pretty dependent about the work of the different other jobs, like the electronical, the polymechanical, automatical. But yeah, I'm pretty proud of myself. It was not perfect, nothing is perfect, but that's it. To conclude, I think I really need to better work in group, and what I will do if I will do this project again is to really include myself in the group and not just work alone. And what I will do again is help developing the project and the CAN.